Hello, I'm Tom Walski from Bentley Systems, and I'm here today in my role with the Water Distribution System Analysis Subcommittee, working on the history of water distribution system analysis. Today we're going to be interviewing Lindle Willnow, who works for AECOM, and we'll be asking him some questions on his experiences in water distribution analysis. And we're now at the AWWA conference in Bethesda, Maryland, and it's the 14th of October 2015. So we'll start Lindle off with the first question of just how exactly did you get involved in water distribution system analysis? What brought you to this field, and what's your background in it?
Okay. Well, I first got involved with distribution system analysis. I think it was my very first job out of college, working for Metcalf and Eddy in 1987. My first project was to update a hydraulic model that had been developed a couple years prior for the city of Marlborough, Massachusetts. And the person who had done the model previously had left, and they wanted me to update the model to include some recent improvements. That was done on a software developed in-house called WDSA, short for Water Distribution System Model. And that was, was a text-based, basically it had just been updated so it could run on a DOS platform, but it was pretty much, by today's standards, a pretty archaic program. But that's pretty much how I got involved, and I think one of the things that I remember from that project was trying to convince my supervisor that it might be a good idea to make a AutoCAD map of the distribution system that relates to the hydraulic model. That was he didn't think that was be worthwhile, but it turned out to be a pretty good, I guess, a precursor of things to come.
Right. Yeah. Linking the hydraulic calculations with graphical interfaces was really big about that time. So you worked with Jim Dillingham, was it? That was the person that wrote it.
Yeah, Jim Dillingham wrote the program about 10 years prior, and as I had mentioned, that was written originally for in Fortran for the old punch cards, feeding into a deck reader and then going to a mainframe computer for compilation or execution. And when I started, it had just been recompiled so it could be run on a DOS computer.
Okay, because that was a program that we used in Austin, Texas back then. And we it was for the time that was a good program.
Yeah.
Before the current generation. Okay, so tell me about some of the studies you worked on. Are any specifically memorable ones that were kind of interesting that you, not just the vanilla studies?
Yeah, I think for 10 years or so, worked on and off with different distribution system models, mostly in WDSA. We did also worked with Jim Dillingham, and he developed a transient modeling program that worked in conjunction with WDSA, and which was interesting. We worked just a couple of projects with that. We did I think a 4 miles of 24-inch pipeline in Rhode Island with the transient. But I think probably one of the most interesting projects that I worked on was for the city of Cleveland. This was starting in 1999, just really as the integration of GIS with hydraulic models was really in its infancy, and Cleveland was really looking forward. They wanted everything. They wanted their model database built so it would work with GIS, and that really was at that time was unheard of. And I think they had some, I wouldn't say naive, but they had they had a very elaborate idea of what they wanted to see from the model database, more coming from a theoretical database design as opposed to working with what the software could handle. And we worked very closely with Paul Boulos as well as the folks at Esri to get to get everything to work together and talk with, to get the database to talk to the hydraulic model. And it was interesting. I mean, I think we had a database consultant working with them and trying to get all these people together to get to try to make it work seamlessly was quite challenging, but it was very interesting. And I think a lot of the things that we worked on then have become pretty standard and commonplace in what you see now in models.
So about how many modeling studies do you think you've done over the years?
Oh, it's probably somewhere between 50 and 75. I don't know if that it's up to 100, but it's, and some range from very small single pump station and a single pipeline to now we're looking big cities where you have hundreds of thousands of pipe segments. So it's been quite an interesting range of different studies.
Okay. You also have some expertise, as you were saying, about transient modeling. About what fraction, how much of your work is devoted to transient modeling?
I would say in the long term, it's been maybe 10 to 15%. We'll get maybe a couple of projects a year in transient modeling, where I may get 4 or 5 a year in distribution system analysis.
So you've seen your company Metcalf and A roll into AECOM,
Yeah.
and so now you're kind of a senior person in AECOM
Yeah.
in the modeling department.
Yeah. So I feel lucky because I still get to do a lot of hands-on modeling, and from big systems down to I will get calls with somebody, an engineer needs help with a design project, and I'll help them to do the modeling work and make sure that that they know what the pressures are and select the right equipment. But I also get called on by a number of our other offices to assist their engineers when they're doing distribution or modeling studies.
So you are no longer. You guys decided not to continue keeping up your own private in-house model after a while. I know it seems to be a trend that consulting companies in the old days did try to have their own models, and
Yeah.
I think they realized that it was a burden to maintain them, right?
Yeah, I mean, I think it really was the move to the graphical interface, and I think that the amount of programming and development required to do that. We'd mentioned Jim Dillingham. He did. Is very very good at the Fortran programming and programming the actual execution and the modeling. But I think the graphic interface and the object-oriented programming was a little beyond him. And I think at that time, Metcalf and Eddy was really not supporting software development. So, and the software that was available was relatively cheap and easy to get.
Could you do much on water quality modeling too? What's your role in that sort of thing?
I probably do a little bit less in water quality than transient, but I will see I'll see those maybe not every year, but maybe it'll come up once or twice. The Cleveland project I mentioned, that was both. They wanted a GIS database, a hydraulic model, a water quality model, and a transient model of their system. So that project, we did all three, and that was a very extensive. We did a lot of water quality sampling throughout their system, and I really haven't seen any other systems. Well, we've had a couple of systems that really are, to get into the details of trying to, simulate the fate of chlorine residual throughout their system. We've seen a number of smaller studies and more limited, and taking available information collected from regulatory sampling and trying to back into what the water quality results might be.
One of the things I talk about some is the divergence between practicing engineers and researchers. To what extent do you follow the research literature and use optimization and such, more cutting edge things?
You know, I try to follow it to some extent, just to see what's what's available, what's being looked at. I think a lot of it I haven't seen, practical applications. I think I was excited, when the genetic algorithms being used for calibration. I thought that was, having gone through a number of calibration, steps in different other models, doing it manually. I was certainly looking forward to having a tool that could automate it, which, it's not really automating, but it's certainly making things move a lot more smoothly. In terms of design optimization, most of the projects we work on, are, they have very targeted needs, and I think, haven't really seen, we've done some master plans where you're looking at, long-term, optimizing when the improvements should be implemented. There are some tools out there, but we really haven't got into using those in practice.
Well, one of the limitations is the assumption that the future demands perfectly.
Right.
And so, how do you handle uncertainty in the future when you're doing these kind of studies?
It's a real challenge. I mean, I think when you sit down to do a proposal or work out a scope with a client, and you say they want to look at these future scenarios, and then you look, you say, well, they've got maybe 5 scenarios for the existing condition, and then you've got to address the current problems, and then do you assume that the current improvements get implemented in the future, and then you have the demands, and then the number of permutations just kind of mushrooms exponentially, and so you really have to think what's important to look at, and what assumptions do you make, and that's really where the engineering judgment comes in, and you try to you say, well, we're going to assume that these improvements are made and that the demands, it's usually, you assume some growth rate and assume that the demands, increase, at that rate. We've had some clients that said, well, we're going to expand in this area, so we want you to estimate what the demands are going to be in that area and update the model to reflect that. But we usually don't get to that level of detail. It's more, we will expect to see a 10% increase in demands, and that's how we'll.
And then there's that ongoing tension between least cost and reliability,
right,
and how to deal with that sort of thing. Okay, you're also now the chair of the Engineering Modeling Applications Committee of AWWA. Do you want to say anything about your role in that?
That's been a lot of fun. I've been I got involved with at the time was the Computer Applications Committee. About 10 or 12 years ago, after the issuing of the M32 manual practice for computer modeling of water distribution systems, and I think I was involved with a similar committee with New England Water Works, and where we did a lot of training, how to use hydraulic models for operators and managers. And I joined the Engineering Modeling Applications Committee to basically look for a forum for like-minded modelers, and there's been a number of really good opportunities to help out, both making presentations at conferences like this. And I think we've become really active with developing the manuals of practice. We're working on now a textbook on calibration, and just getting the message out there, and letting other modelers know that there's other people out there like them that we can work with.
Okay, so to summarize now, you've been at this for probably over 30 years now. So how do you see the past going into the future? What kind of things do you see happening?
I think we'll see, as has been the case for the last 5 to 10 years, the integration of GIS and modeling, so that the data and the data becomes more useful not only to the modelers but to the utility, and so that somebody out in the field with a handheld device can pull up a GIS database, but part of that database would be modeling results, so they can so that extending the use of the models beyond just for analysis, and so that if somebody's going to close a valve, they know what the impact is. If they're going to open a hydrant, they can click on the that hydrant and have an idea of how much flow they might expect to come out there. And I think that, and I think the integration with operational information from SCADA systems.
Okay, great. Okay, Lindle, well, thanks a lot for taking the time to be interviewed and share your experience with people. We always appreciate the contributions from senior people like you. So thank you.
Yeah, you're welcome. It's been a pleasure.